Hello everybody, welcome to another stream. How we're doing? So last stream we got this shader up and running called prepare clusters at level of detail, and basically we go over all of our volume instances and we go down the tree of clusters and we try and select the best one to render given a height in pixels for the cluster. And if we do, we put it into an array for volume clusters to render. And then we started thinking about how are we going to ray trace against these we're not ray tracing against the clusters, we're going to be ray tracing against the spheres in the clusters. So now we've got this cluster and we're like, hey, this thing is something we want to render. We've got this sort of tiled based ray tracer, so you bin your spheres into these okay, say if there's some spheres you want to draw, there's one sphere there, one sphere there, and one sphere there. We need to make sure we bin this sphere here needs to be binned in this tile, that tile, that tile, and that tile, right? And these two need to obviously be binned in this tile. So we need to go over all of our clusters, get all the spheres and bin them in everything. But before we can do that, each of these tiles can have it has an array, a dynamic array of spheres. So we don't really know how many, you can fix, the one method is to fix allocate this array here. You might go, every tile can support, 64 spheres. But when you overflow that, it's not really great, is it? You'll start seeing flickering. And what happens if you've got tons of spheres in one portion of the screen, but not tons of spheres in other parts of the screen, right? So this is where you need to so we're going to go with more of a global approach to this allocation thing. So we need to sort of at worst guess what is going to be in all of the tiles, and then we'll have one big buffer where all the spheres go, and each tile goes, hey, I found that there's at worst going to be 8 in mine, so it pre-allocates 8 from here. So there'll be an array inside this array in a sense. There'll be a start and end index, or there'll be 8 slots or whatever for that tile. And then this one here is just hey, I'm going to need 16 or whatever. So that this takes a slice of 16 from here. And yeah. So basically, end of last stream, I wasn't sure if this was the best way to do it. But I think about off stream, it seems like it is the best approach. But if it does get slow doing this, then we'll add a special path in. So what does this code do here? So this code is hey, we found a cluster we want to render. So it needs to now go over all of the tiles that the cluster overlaps. So we've got a lovely little screen rectangle of the clusters. Here's our cluster, we've got the screen rectangle. So we can see how big the height was in pixels to see if we should render it or not. Now we have that, we can be oh, this cluster overlaps all of these tiles. So iterate over those tiles and add, just add the number of spheres which are in the node. Just add that number to the spheres count, and then we'll if inside that tile, and then we'll allocate it afterwards. So what is bad about this code? Well, if you have a cluster which covers the whole screen, which I don't think we will, but it could be possible. There could be a lot of tiles. They're only 16 by 16 in size. This is not a precise representation of that. So you could technically be iterating over a lot of tiles if your cluster is huge. I think on my 1280 by 960 window that we pop up, because it's not a full screen window, that's like 50, sorry, it's 80 by 50 tiles. So if you iterate over 80 by 50, quick maths, that's 4,000 tiles you've got to go over on a single thread on a GPU in a for loop, which is not really ideal. So anywhere sort of like that's the maximum number basically for our current screen res. But as you go higher screen res, that will get worse. So there are ways that we could solve this problem by detecting that it is going to span multiple tiles and handle that differently. But for now, I don't think it's going to be a big problem. So we'll just tackle this later on. To handle the case where we need to iterate over a large amount of tiles. So what was it? I was going to do for that. Maybe push into temporary buffer. And then go over all the tiles and check. So you can push it on the back of the buffer, and then you know it's too big. So you can push it on the back of the buffer, know it's too big, and then like you could sort of like this can be solved by pushing from the back of the BC volume clusters to render buffer, pushing from the back end, right? From the tail end of the buffer, then dispatching a different compute shader that sort of gets a thread group per tile and iterates over all clusters. So you do 32 clusters, 32 at a time. Maybe that's the other way we could just do it. Yeah, we'll see about that. Because we can make it do... We could try that later, I'm not fussed. I think this is a good enough approach for now. Yeah, so this actually kicks off and runs, which is great. So what I want to do is... move on to the next shader, which allocates the... So should we call this the... we should call this the sphere's capacity. So we up the capacity. All right. Okay, so the next thing to do is to get the... Let's open that can of Coke. Getting a bit tired already, so... The energy level's up. Yeah, so we made like an allocate tiles shader. Or we already have one laying about. So I just want to find that. Tile bin, okay, it's right below our current shader, I think. Yeah, so tile bin alloc. So this shader just runs, you get 32 threads per thread group, and you're then going to launch. And then each thread gets a tile, and it simply just sort of like sets where the spheres start in the massive spheres array. Now we should probably make them ellipsoids actually. Yeah, maybe we should change this to an ellipsoid ray tracer naming, but we'll see. We'll look into that. Actually, it's easier to just get the sphere one working because we already have the code for that. Ellipsoids will be a little bit extra code, but we'll do that when we get up and running. So we just need the number of tile spheres allocated next index. Is that set to 0 somewhere? Uploaded CPU side? Shouldn't be. This should kind of be cleared. But yeah, the capacity is definitely uploaded from CPU side. Although that shouldn't be reset here, it should instead be reset in frame init. So frame init's just a shader that runs so once at the beginning of the frame. And it just initializes all the bells and whistles, you know? So there we go, there's just one more thing. So this is the new one, that's the old one. So we're going to take yeah, sphere tiles count. Why is that uploaded in those constants? That's before we had this globals buffer, you see. That's why. So we've got a tiles count. Tile dim, grid dims, tiles count. So grid dims would just be, sorry, tiles count would just be grid dims multiplied with each other, you know? So .x multiplied by y. So that'd be like 4,000 as we saw earlier. So we launch, so that needs to get launched. At some point, but we first need to get this shader just cleaned up a little bit more. So now pull that global out of the global buffer and say if tile index is greater than this, greater than or equal to, then we return. It could technically be better to stick it in the push constants, but it's just more effort that way. This way it's just globally accessible. We don't have to worry about passing in different data. Maybe the same could be said for a lot of things, even the resources themselves. Yeah, but then you have to do the sync code still. It's a bit clearer if stuff's passed in. Anyway. So max spheres start index, what does that mean? Well, we're gonna have a lot more spheres than that. Right. is to stop it from overflowing the buffer. Yeah, so if you overflow the ones towards the end, we end up sharing the same space, unfortunately. Well, it's just any one of the spheres will just get capped, yeah. I guess what we can do then is, so you'll get your start index, we're going to do the min thing. I think spheres cap is a little bit of a weird thing, we shouldn't have that anymore. Maybe we can. Yeah, okay, so I think what we'll do is we'll let it allocate. Then if it goes greater, you probably min it with spheres cap. And then you want to make sure that the spheres capacity. So if you now overflow the end, right? So what you want to do is do something like, given this start index, I guess. So let's just copy paste that. So eventually you'll set it in there, right? But before that, you want to say, you basically want to say, here's the new sphere's end index. And that is sphere's start index plus the capacity that we've asked for. And then if it ends up going over, so you say if sphere's end index is greater than or equal to sphere's capacity, you make the new sphere's cap be something like difference between these two, right? And then that way we can just store the new sphere's cap in there as well. Just write it back as well. Sorry. So that should basically allocate each tile's array of spheres, because we've already sized it up now. We just basically bump allocate it with this, and then if we overflow, just trim it down. So you will get some glitches with this. But yeah, hopefully we never overflow. Yeah, so you just get flickering basically on the screen. So you don't get any repeated data being reused. Just one frame, one tile will have an array of data, another frame it might have none, because it's just the way the compute shaders got scheduled and we overflowed the buffer. That should be alright. So let's try and launch this one now. So from the CPU side, we're going to find where we do that sort of prepare at LOD, prepare clusters at LOD. Here's our go. So just we'll launch for every level of detail and go down the trees and sort of see which clusters we select to render. Now so I'm going to take this one because it's probably quite a similar one. So this is our, so we're going to plug in this one here. And it only takes in one of these, and it's just this tile spheres or something like this. Oh yeah, I've already got it. Yeah, it's up here. Excellent. Yeah, I'm a bit... Now for this globals buffer, I don't know how much stuff I want to pass in via the push constants. It's better to pass stuff in via the push constants. It's just more effort. Because push constants are... they're quicker. They just go right into the registers on the for the shader. There's only a small amount of them. Whereas globals, you have to pull them from a storage buffer or a structure buffer. So it's not as good, but it's probably okay. But which one is it again that I need? Right, I'll just ignore that problem. It should be fine. I can click when I got a whole rendering thing. I can convert it over to fully use push constants and just see like how much better do we actually gain. I doubt it would be anything. Or go the other way and convert it all to using globals for the most part, and only use push constants where necessary. So this one needs to launch just like a regular dispatch. So I just need to get the right shader. So we're launching again. We are launching core divide round up. So along the X, the thread groups, the number of thread groups is the number of tiles. Divided by 32, because that's how many threads we've got in the thread group is 32. So we need to divide round up that one, then 1, 1, the rest of them. So that should be how we launch that shader, and then we can plug in our... yeah, then we need to take our binning shader and get that up and running. So hit compile. What's going on here? Nothing called sphere tiles, just called tiles. Okay, there we go. So now we're going to launch this shader and just make sure it works. So yeah, the stream dies. I'll be right back. It's just the AMD driver sucks and it likes to crash and burn the whole system if a shader crashes. Alright, we're still here. So here's the new shader that's running. It takes like a very short number of time. 86 microseconds. Is that right? Or 8 microseconds. Something like that. It's quite... wait. Okay. So the next shader we need to write is the actual binning shader. Now I've done one in the past, so we're just going to grab that and then adjust it. So what we need to do is we need to launch over all of those volume clusters to render that we poked in this prepare clusters shader, and then simply take all the spheres, get their screen bounds, and actually goes this diagram. Get all the spheres within a cluster, get their screen bounds for each of these spheres, and then iterate over all of the tiles that they go into, and then atomic add them in. The other way is we could dispatch over all of the... Yeah, wait, I think that's alright. Whereas you have a lot of atomic operations running. If you do it that way. Or you could go over all of the clusters you've got. Sorry, all of your... So you probably want to make... Let's just try it and see how bad it gets. You can always just change it later. Yes, the algorithm is gonna... So this tile binning guy. I don't know how much of this we actually want to keep, to be honest. Probably some of it, actually. For that. Alright, so it goes into this one. This one's just gonna say, you know, tile bin. Sphere ray tracer. Okay, put that in there. Tile bin. So what do we need to get passed in? The volume clusters to render. We'll have that count in another buffer somewhere. And the tiles. So we're going to be launching over 4x4x4 so that we can access... Each thread gets a sphere. Yeah, each thread gets a sphere. Now the problem with this approach is if you haven't got a full cluster that you're rendering, there's 64, you're going to have wasted threads, right? And they're not going to get... They're literally just going to be idle while we do all this maths calculations where we transform the sphere from local space all the way into view space. So hang on a minute. I've just remembered something that I wanted to check. I don't think my what local from view space was correct in one of my other shaders. So let me just quickly test that one. So in this prepare clusters at LOD, we made this thing here, this top left bottom right thing. Now, I think it should be in the middle of the screen, and I remember the numbers being kind of lowish, like in the hundreds, in the low hundreds, but not the sort of high hundreds. So I want to print those out and also see where GPU hprintf. So we'll just print out like B L T R. Okay, so if we have this printout, what are we comparing it against? So we make that sort of view from world transform. Now I completely don't have anything, it's identity actually, because I disabled all this movement controls and that, because I want it to just be in the middle of the screen, right? So I think in our volume instances, yeah, so I think we put it at, oh, x50. Can I remove that, make it 0 there? And then 512 off into the distance, down the Z, and obviously scaled to some degree. So we sync that and run that. Oh, I printed it out as float, but it's an integer. Yeah, classic. Alright. These are about like, I've seen some 300s on the bottoms. Okay, 100, about 150 on the bottoms, and the top go. Wait, no, sorry, we're talking about mainly about the left and the. Okay, bottom and top goes from 100 to about 350. I've seen. And the left-hand side. It goes from about 150 to about 400 on the right. Okay, so the resolution that we've got is actually, we have hard coded a 1280 by 960. So we're only getting the low hundreds. That's kind of in the corner of the screen, but should be in the middle. So I think what we're not doing is offsetting this by, and I think I kind of copied this code from like another place, and maybe that's why the camera was maybe a bit offset, or felt a bit offset, or the final rendering felt, or something like that. So essentially, if I just was to draw it out, when transforming the origin, way of saying it, I think it'd be something like that. Or it would be from up here actually, or something, I don't know. Wait a minute. What's going on exactly? Right, I know the answer now. So what happens is the origin is here when it's in view space. And so your vectors come from here. But when they're in screen space, the origin comes from here, right? So we need to move. So when we translate it back into screen space, at this point we have negative, I think that's right, negative, or maybe, yeah, but that were true. Yes, anything on this side should be negative, and anything on this side should be positive, right? X, right, X. Hey there, 3D. Hey, it's been a while. How you been? How's the project going? It's going good, man. We just got the we've got our LOD cluster system finally working, but we haven't got it rendering yet. But we've been testing the crap out of it with debugging and stuff. So we've got 256 cubed volume of spheres been LOD'd and constructed on the GPU. We draw a simple sphere and fill that with spheres. Basically, it just gets filled with spheres. So we're just trying to get it to render right now, and I'm just trying to plug it into the tiled ray tracer, if you remember that one. Funny, Ryan Fleury was also thinking hard about relation to screen space and the rest. Oh, okay, interesting. That was in his stream. Yeah. Yeah. I don't use a projection matrix either. I sort of manually just put it through. Do the divide by Z and that. So yeah, I just want to make sure this code is correct. Hey there, Rizoma. How's it going? How's it going? So yeah, I don't know how. Like, if I move it to the left just by a little bit, should I start seeing some freaky numbers? So if I say -10, I should start seeing some big underfloat numbers. Not really. This is the right one. So yeah, so basically you need to plus the half. So past me has done this. I just forgot to copy this. Alright. So past me was on it. So where's those screen dimensions? Global screen dims. There we go. Oh, I love the globals buffer. My pal. So we need to add that to all of these boys. There we go. So if we look at the corrected numbers, they should kind of be like in the middle of the screen. Now, yeah, ooh. Yeah, they're kind of a bit to the right-hand side. Maybe that's okay. Let's offset this by 50. And see if it moves more to the left. Yeah, it's moving more to the left there, that's good. Yeah, I don't know what's up exactly. We'll have a play around with that in the future, I guess. But yeah, okay, I'm glad I remembered that. So one thing is we actually want to make these signed numbers, because if you go like to negative, like you need to keep the sign basically, right? And we need to do some sort of like, hey, if you're off the screen. I guess that'd be part of the occlusion test. Excellent. But yeah, That's a later thing. Right, so I'm glad I've looked into that. So where was we going into? Oh yeah, the tile binning stuff. This is gonna be amazing. All good. I also saw a little slice of Flurry's stream and need to restudy my linear algebra. I implemented my stuff and forgot about it. So what about you not using HCs? Yeah, so with the linear algebra stuff, it's quite interesting. Yeah, for me, I sort of remember stuff, but then if I don't do it for like a month, I definitely forget things. And especially when I'm tired, my brain's like, oh, I don't remember anything. But then like eventually, but then after a day of like, or I guess a little bit of a session of not being familiar, like the next day I'm just like back in the zone with the stuff I need to do at least with the linear algebra. But not using matrices. So we do use them, right? We have a 4x3 matrix called transform 3. We have one of these boys. So the axis vectors and then the translation vector, if you will. So we have a custom 4x3. So it's basically 12 floats instead of 16 floats. And it's got an implicit fourth row of 0001, if you're familiar with matrices. So yeah, we got this whole thing. So we still use matrices, but what I'm saying is when I go from view space into screen space, so I mean, this is in view space, you know, from here. When I take into screen space, I don't bother using a projection matrix or anything like that. Basically, I just use I just do it like with scalar maths, just manually. So I divide by the z, and then calculate the height of the near plane, and yeah, map it that way. I can't even find the maths anymore. Yeah, so that's interesting. This one goes out to the. Interesting. Right. What am I looking at? Oh yeah, this was the maths up here, wasn't it? Yeah, so you sort of just. Wait, where is it? Where is that? Yeah, so take it from view space. Here are all these 2 points in view space. So to take it from view space, you just divide it by the z. So you take the xy divided by the z, then divide it by the pixel size in near clip plane, and that'll give you the size or the points in screen space, whatever. There's quite simple maths just to get it. There's just a couple divides there, unfortunately. Well, a couple. And you calculate the near. Yeah, you still need the field of view, basically. The so you get the distance of the near clip plane, which is also the height. So you have like a camera. This is stuff like I just sort of have learnt, but I'm not sort of an expert in this. But if you will, you've got the camera. The near clip plane is here, and this is, if you will, where the screen is, right? Where you essentially got the pixels in a sense, right? So the distance from here to here, this line here, is near clip plane distance, so it's just tan half of radian's field of view, and that'll get you that number there. But this distance here is also the height of this guy. So if you draw it in a bit of a different perspective, where you're seeing kind of like more of a, like this height, the height of this, if you will, is that. So with that, you can say, oh, my near clip plane height divided by the screen, how many pixels on the screen, y, and that's the pixel size at the near clip plane. So you can use that to sort of map it back into screen space by dividing it again. Maybe there's a better way to do this mathematically, more simplified, but that's just what I've cheesed together basically. But yeah, that's basically where I'm not using the matrices and just doing with scalar maths instead. Playthrough. No playthrough yet. We're just getting graphics on the screen for a custom renderer. So do some tile binning now. So yeah, so I was thinking about like this tile binner. We can give it a thread per sphere, but if the sphere doesn't exist, it's a wasted thread and it goes over all that view local to view space calculations, and that can be quite a waste. You're not using the raw power of the GPU there. So what other ways could we architect this tile binner? So you've got your screen tiles and you've got clusters. And the clusters have spheres. And you've got to transform every sphere onto the screen and then go over all of the tiles. So the approach you could take yeah, maybe the approach we have is the best one, because the other one is you can still go over all the clusters and do a for loop over all the spheres. But then translate those. And then the time where you get a wasted, yeah, and then the waste would come in the for loop when some clusters have larger amount of spheres than other clusters. And the shader would just run longer as well. There'll be wastage there. The other approach is, instead of tackling it from a instance point of view, you tackle it from the tile point of view, where you say every tile looks over every single cluster. And then you would have the same problem again with that for loop. So I think this is probably the best approach we can think of right now. Yeah, let's just roll with this one. One big thing I wanted to ask you, since this is all GPU stuff, what are you doing for debugging? Why do you not do CPU first? Maybe I'm saying something stupid. So we've got printf, right? So we already have kind of like a better debugging experience than, like, you know, most people get with GPUs. And I think they've done printf recently in GLSL. But yeah, so we've got printf, so we can debug actual values of things. Very soon, after I've got this thing rendering, I want to do some improved debugging tools where we have the ability to say, hey, I got this vector in GPU code. You know, I got this sort of point or whatever. Can you sort of like debug draw a point for me, right? And it would literally just debug draw that in world space on the screen using some other renderer from shader code and from CPU code as well. So GPU programming is a bugger. But the best thing about GPUs is the hardware, and it's quick. And if you just implement the same thing on CPU, and you want it to be fast, you've got to use SIMD intrinsics, and then that doesn't translate to being GPU code. Also, if you're doing stuff with textures as well, you might have to manually write that CPU some of the logic. And yeah, yeah, it's just better if you just write it on the sort of with the technology you're going to be using. And it'll just be, I'm trying to sort of gauge if the code I'm running is going to be performant enough. So I have to use that GPU tooling basically. I couldn't gauge the CPU side. It's different hardware. So yeah, that's why we're using GPU. So we want to go over all of the, so we want to fetch the cluster. So how are we going to do this? I need a group index, isn't it? Something like that. And I can get a cluster ref and get all of it. Yeah, so all the stuff I want. So here's how we do it. We simply we use the group index dot x. So this would be a dispatch indirect. So these are how many threads within a group. And we use the group index to get the volume cluster ref index. Or sorry, cluster to render index. So then we do cluster to render index. If that is greater than, then I think we've got clusters to render. Where's the bugger? We bump it in there. Clusters to render count. I could have just guessed that. Clusters to render count, if it's greater than that, we return. Right. Nice little check there if we've gone too far. We should never go too far, but it's just a safety check. So now we get the clusters to render. Volume clusters to render. Then we put in the cluster to render index. Now we use the cluster reference to get the instance data and the volume, and then the node that we're referring to, the cluster node. There's a whole bunch of different reads there. Yeah, I thought you might be able to translate it, but yeah, I got no experience. It was speculation. Awesome. Yeah, no worries. So now we have the cluster. So this will all be shared between the threads. So all these values that we'll load in these structures will be in SGPRs, because they're all going to use the same. All threads are going to use the same data. So now we've got to make it work. So we've got to construct the sphere in local space. Wait, did we go to use ellipsoids in the end? Or did we just use spheres? I'm struggling to think, what did we do? So we haven't got the array of spheres yet. Huh? Okay, I don't think we've got the array of spheres yet. We'll just use the sphere for now. Or should we use the ellipse? Because otherwise you can't do non-uniform scaling. You might want that. Yeah, I think it might be a little bit more. Let's just keep with the sphere. Keep with the sphere. So, center position, radius, color. So, what am I doing here? Okay, so cluster LOD. In local space. Yeah, so we kind of want something like this. Right. So we got the cluster's level of detail. We have the cluster's position in local space. That's the cluster's position in local space. Sorry, in LOD space. Bit different. In cluster LOD space. Then we move it into being cluster position in local space unorm. We're still a little bit off. We now need to create a new one. That's be known as sphere position in local space unorm. So this one takes, and we need to add, wait, it's unorm. Yeah, we need to get the number of, like, how big is a sphere in sphere position in local space. So we need to say how big is a sphere in sort of signed norm space. Sphere, norm, sphere, radius. Or do we want more of like the diameter? What do we want? So sine norm is -1 or 1. So in that -1 to 1 space for the whole volume, what are we? So you got 256. Where's the constant? So it's how many spheres across? So it'd be 2 divided by that, right? So that's a nice constant. So this means we multiply our sphere offset from the cluster. We can just add it to this cluster position in local space. So it's going to be add mul s so here's our offset vector. So we've got to calculate our offset coordinates. So given this is our local space offset, this thing here. Is that right? Yeah, so that'd be SV dispatch. So I guess we'll put this in a smaller thing. So this would be like sphere coord. Probably one that's a float. Yeah. Dispatch local. So that gets us these numbers here. So there's 64 being launched. And so this will get us 0 to 63 inclusively for the X, Y, and... Sorry. This will get us 0 to 3 inclusively for the X, Y, and Z. And so there'll be 64 different possibilities there. So we then multiply that 0 to 3 inclusively vector, right? With this sort of, how big is a sphere in local space? And that will then get us our offset into here, but I think we're still missing something. So actually this has added something. This has added the half dim, so it's already put us here's our cluster. It's already this variable is actually there. That's the position it's pointing to. Whereas what we probably want is the position to point here. Then we apply our offset, which gets us to the lower left of our sphere, then apply the half offset to put us there, yeah? So this needs to get deleted. Cluster, bottom left, in local space, unorm. And then there's the signed norm version. Then we take that. Oh, it should be bottom left. Now there's one more thing. We then need to add. We need to add S half of this, and that'll put us in the middle. You know, put position in the middle of the sphere. Put position bottom left of sphere. Right, now we need to get that sphere position in view space. And there we go. So that's transformed it all the way from view, to view from local. What else do we need? It's that sphere, isn't it? So the radius obviously needs to come through as well. So the radius is sphere radius in view space. Now this needs to be handled properly. So that would be this sphere dim divided by 2. That's the radius. That's like the diameter. Or it was the diameter, then it's made into the radius by dividing by 2. Then you need to offset a vector. So don't do the translation. from local to view. Voila. So there's our two big things. The color we're just going to make up. We're going to pull that out of thin air. We'll just make it a red or something. Now, something that we need to do now is we basically need to do this, right? Where we do the binning again. So we need to calculate the screen bounds. So I've got this calculate screen bounds of sphere. So I need to make that sphere object again. And then we need to do this sort of like binning thing. Yeah, let's just take, let's just delete all the other code. Man, I much prefer this new one. Hey Ojilla, how's it going? How you been? How's it going? Man, this is much more improved, this version. Excited to get this thing working. Okay, so yeah, definitely need to do a, yeah, so this sphere code is going to go eventually. It's just what is, and we'll replace it with ellipsoids. So we're just going to quickly cram our variables into here because it just doesn't matter. And the radius is sphere radius. I'm going to make it red. So I already transformed it. No pixel size at that. Calculate the sphere bounds. Excellent. From screen space to tile space. And then go over all of the tiles. And bin. So this is the code here. So this is going to go over all the tiles. This grid dims can be accessed from globals now, the globals buffer. Good old globals buffer, where you at? That's the code. Got the NURBS working. Oh wow, awesome. So were you doing like a NURBS renderer? Awesome stuff. I was looking into that. I was wondering whether or not to use that as my sort of rendering technology. Did you find good resources on it? But yeah, I settled on this sphere ray tracer as the sort of different thing. I have some improvements to make. Yep, don't we all? Don't we all? Have you got any pictures actually? Show me pictures. So we got this. So we're going to the tile. There's not an insert index anymore. There's a count, and that you. Yeah. So what's interesting is you're going to be atomic adding like 1 across all threads within the wave. All of them are doing that. And they could possibly... Yes, this could definitely be made better, I think. But I don't know how yet. So we can think of that in the future. Sphere start index. Yeah, base index plus insert index. Lob the sphere in there like a champ. So I need to actually have a spheres buffer. Sphere. Tile spheres. I could just call them spheres. Rightio. So just got to get it all plugged in now. And then away we go. So does that compile? No. Okay, I need the volumes. This is all passed in as well. And the volumes. And the cluster nodes. Which is kind of obvious. Eh. Oh yes. I forgot about this. Yeah, technically you need to make that into a vector. And then you probably need to just... I'm just taking one component from it. Yeah, that's not ideal. But it's assuming uniform scaling, isn't it? We'll sort that out in the future when we use ellipsoids instead. Global screen dims, isn't it? Wait, do we need this anymore? Alright, we're nearly there. Bounds. Bounds. What about it? Tile size. We'll tile dim. Alright. Output dims. Wait a minute, didn't we already yes, I've already fixed that up. Number of tiles along the x-axis of the screen, along the y-axis, and repeat. Oh. Right, compiles. Bing. So, see you, Rizuma. Thanks for popping by. Have a good one. Right, let's have a gander at the image. The resources were mainly just maths, and code was annoying to write because maths didn't make sense to me. Okay, I can imagine that. Nice, so you got your points, and you're sort of, I guess that makes sense. Wouldn't it, isn't it the wrong way around? I don't know the maths, but isn't it, or maybe, yeah, I don't know, I'm not researching it, but so if you move that, so what you've done is you've moved this one out, you've moved this one from here to here, and it's sort of, because you moved this one from here to here, it's moved this part of it to the left. Is that the way it should work, or should it move it to the right? You know what I mean? Uh, it should be touching those endpoints. It's the way I put the points, which is why it is reversed. Oh, right. So this should be touching here, and this should be touching there, and these are sort of different. Right. I think I kind of get what you're saying. Maybe it's like a different relationship with the points, basically. Right, but yeah, you know what they mean more. Okay, it's cool though. Nice stuff. Are you gonna send it to 3D? Or is this um essentially I need to not weigh the endpoints into the equation. Right. Cool though. How are you rendering that? Are you using yeah, what are you doing to render that? Um alright. So now we've got to launch it. So we're gonna go CPU side. Go ham on that. Find my ham. So damn it. Prepare. Bin alloc. So tar bin allocate. After this, we need to put the binning code. So here's one I made earlier, but I don't think how much of it we can actually be able to keep. Right, so we need all these boys. We'll need tile spheres. You know, a lot of this is actually correct. Need the tiles is all. And we need to use the new constants thing. Rightio, so we just gotta sort this out. Sphere ray tracer tiles. They need the sphere ray tracer spheres. Man, I got so much code this needs to get deleted when this works. So I'll go through and just delete everything I don't need anymore. Alright. I don't know why that's there. Okay. So the next thing to do is to find sphere ray tracer spheres buffer. No, to allocate this with enough spheres. So I'm going to take this and just make another one. I'm going to make another one and the other one will just get deleted. Spheres buffer. Ray tracer spheres. Spheres time. There you go. So this will be ellipsoids and we'll change everything to be ellipsoid. But for now that will just have to do. So with that means yes. So read only on the instances, read only on the volumes, read only on the cluster nodes, read write on the tiles, because we atomic add, right? And bump allocate them into the tiles. So they've already got pre-allocated range, like a max capacity allocated, but then we bump allocate and we bump insert them in. And then we then read, probably just write only on the spheres, because we just dump them in there. Rightio. So, how many do we dispatch? That is a good question. So, we launch how many that we have that we know on the GPU. So we need another sort of one of these dispatch indirects. So this means that the GPU came up with the value of how many we need to render. So the GPU is like, oh, I've found, I don't know, 500 clusters or whatever. We need to launch this for however many clusters we have. So this will be the sphere ray tracer. I need to make this field. Sphere ray tracer dispatch arguments. So we need to go into the globals and add yes another dispatch indirect. So sphere ray tracer bin tile bin So how does one populate this guy? So when we allocate the tiles, we know we can get like the first thread to sort of just do that. So when we allocate the tiles, we can be like, hey, if you are the first thread, not to be launched, but thread number 0, because compute shaders don't launch in order. So we're just gonna now fill in this thing for the next stage. So we'll say global dot x equals, and there'll be another it comes from another place in the global memory. Unfortunately, you can't tell the GPU to be like, oh, you just read that one value. It's got to read 3 values. So you have to do silly stuff like this sometimes. So the value I want to read is volume clusters to render count. So we just do that. And then y, okay, I guess we can just do that once. And do a 1 and 1. Right, so set that up. There we go. So then this guy is launched with this many groups. So that's 500. There's 500 of these being executed with this 4x4x4 threads. Okay. So I just output the coordinate points to the file and copy it into demos for now. Then I write the line renderer for a line renderer and render a tiny amount of lines determined by the resolution. Oh, I see. Okay, fair play. Cool. So you just sort of writing the NURB, figuring out the NURBS formulas, right? Cool. Excellent. Right. So we're getting there now. So afterwards we'll be able to hook up the sphere ray tracer and see how that works. So, all right, we've made a new shader, which means we're going to run some more code, which also means the AMD driver could crash because it doesn't like it when you do something, when you make it segfault essentially. You make this GPU segfault, it crashes the whole desktop, so I'll be right back if that's the case. If not, we'll be here and celebrate. Here we go. And we're here. Been pretty lucky on that lately. So this takes 1.2 milliseconds for a single volume. That's not good. We haven't got any occlusion culling in yet, which is going to be essential, but this is this could also be because the algorithm we decided to do for the binning is not good enough also. Like, I think it's this atomic add. Like, they're all going to be touching, like, the threads within the same wave are going to be touching the same tile. And I'm pretty sure because it needs, see, I'm not sure how the GPU hardware works on this factor, but because it needs a return value, it definitely needs to sort of synchronize between the caches. I think if it doesn't need the return value, I guess there could be some optimization where the GPU just sort of like does the atomic. Like it wouldn't need to wait before it executes the next instructions. Basically, it could just sort of maybe give it to some other thing to do it. I don't know. I'm not sure how hardware works at that level. But what will happen is it's because there's this atomic add. If you've got two, so you've got compute unit here, 1, compute unit 2. These have 32 threads that run in lockstep, and they've got their own little caches, block of cache money. So basically, this one is like, hey, I'm gonna add a sphere to this guy, and then this guy comes along and goes, I want to add 1 as well to this. So what happens is this one wins. Yeah, this one wins, but essentially, depending on how the GPU is architected, it's maybe got like an L2 cache where they can sort of communicate over, but it's got to essentially write this back into the cache up here, so it's visible in here, and then this one can sort of like pull it through, so that sort of takes time. So I have a feeling that this is probably going to be a problem. Like you want that to happen less often, right? As less as possible when you design these sort of atomic algorithms. So you want to try and avoid right to the same location, basically. Where possible. Bum 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 bum. Yeah, sometimes that is not a problem because the GPU just, when it has its compute unit, whenever a compute unit gets stored, it just like goes, oh, I've got this other shader I can switch out to, and it can literally just like context switch and run another shader, and it's pretty good at doing that. So sometimes those problems are not too bad, but when you've got all of them that do it, I wonder what happens if the same compute unit touches the same tile with an atomic. It might be able to do it locally. Like, no, it's touching the same memory locally. But maybe they're not going to happen all at the same time because different threads have different bounds. So one could start on the left-hand side or like x27, and the other one can start at x26, x26, the one just before it, and it then goes to 27 in the next iteration. So I wonder what happened in those sort of circumstances. So yeah, stuff to fiddle about with, but for now, that should be alright. So now we're going to get out our lovely ray tracer tiled. So we're going to take this guy and ray tracer tiled. So this one, we just got to get it. All the living crap is all this code. Oh, the BVH code. Right. So we're going to refactor. So an output texture, the spheres, the tiles. Right. Now this needs to use the sphere ray tracer tiles. It's the new one. And then there's no occlusion. Yes, that's another thing as well we kind of missed out on. Is each of those spheres needs to be occlusion tested. Well, none of that crap needs to get passed in. So can I quickly just go back to the shader we wrote? I need that code basically. So I need to say, oh yeah, you got the sphere. Then occlusion test. Me please. Probably with the screen bounds. There. So we want to check to see if the if it's occluded, and if it's occluded, then just don't render it. Don't add it to this. That's another way how we sort of make it faster as well. Great. So this tiled ray tracer, we'll grab this boy here, and we'll get this ready. Should be quite easy. To get your tiles, you get your spheres. We launch over the whole screen resolution. So our local group, well, we'll get into shader and see that in just a minute. Let's just get going. On one. Where's the spheres? I forget. These should all be. These have not been doing their thing. With the global buffer, this is not good. Shoot, give me a second. Read write. Read write on the global buffer. Was this read only or something? It's probably just read only. On the global buffer, this one will probably just be a read only. So surface, write only, there's the output. Right, read only, write only. Excellent. So effectively what we do is we've got a thread group of cell size. This is just 8 by 8 at the moment, but it could be more. So our cell is like, I don't know why. So you still got tiles. Tiles are 16 by 16, and a cell, I guess, is just a smaller tile within this in the tile. Yeah, why did we do that again? I forgot the reason why we did that. But yeah, there's no specific reason. It's still we still pull the spheres out from the tile. So let's just get this all sorted out. So these are tiles. So we get the spheres count from the tiles and the base sphere index within the spheres buffer. A lot of this stuff with this. So yeah, so this is like 8 by 8, and we launch enough groups to cover the whole screen. So essentially, yeah, so essentially the whole each thread gets a pixel on the screen, and then it's going to do the ray tracing from there. But we should be able to go. There's no out of bounds check though. Oh, the out of bounds check is here. Yeah, I was going to do some sorting. This is a thing we need to do in the future. Don't mind me. Right. BC output dims. Right, so this should actually be a global GFX. Global screen dims. Just replace all that we see. There's a lot of comment out stuff here. I think I've got like debugging visuals, which again could just be replaced by some simple debugging thing. Some debug shape renderer, basically. But we just need to write that. And that'll be one of the first things we do after this code here. Tile size, let's amend that one. So tile size is going to be, I think it's called like sphere ray tracer tile dim. Sphere ray tracer tile dim. Right, that's done. Next one is this tile grid dims. There's only one of those. It's basically the same thing. Grid dims .x. Cool. So we get the tile coordinate from the pixel. So we get a pixel coordinate, calculate the tile coordinate, calculate the tile index. Grab the spheres count and the base sphere index out from the tiles buffer. Get our coordinate as a floating point number. This printed the coordinate out, or it rendered the coordinate out as a debugging thing, so we'll keep them there just for a sec. This one calculates the ray tracing ray. It's in view space though. Right. This is trying to debug render the occlusion texture. Yeah. Maybe we'll keep that in because we might be doing this soon anyway. So just leave that in there. It's okay. It'll be useful later. So this is where we do the ray tracing. So essentially what we need is an ordered list of spheres from front to back, but we haven't done that yet. So every sphere goes over, sorry, every pixel looks in the tile array. It has its array of spheres. They should be ordered front to back, and it will check for this pixel. It will check all of the spheres that are inside the tile and sees if it hits them. And essentially, it's going to be able to do some anti-aliasing as well, because and transparency, because we're ray tracing front to back. That's the plan, at least. So this is the spheres. We get the sphere. Oh, shoot. Do we push it in view space? Yeah, you push it in view space. So it's in view space checking. Yeah, this is it. So it's doing a view space comparison. To get the sphere out. This is debug rendering the bounds and stuff. We could probably get rid of some of these. Right, so there's a ray versus sphere. It's in view space. We should probably move it into world space. Like move the ray into world space and do this in world space. Because afterwards we might want to do some other stuff in world space with it. Maybe. Then this is saying if it does not do the anti-aliasing. I think I can improve this code a bit. But the basic idea is saying if you miss by a pixel, or if you miss by less than a pixel, then yeah. And it currently is in the closest hit, so it's kind of doing the anti-aliasing. But in future, we'll just be sort of accumulating the alpha and then stopping when we have something for the opaque. Then this one is saying, so after you've processed all the Raver spheres and got your color, your closest hit, it won't be called closest hit anymore, it'll just be an accumulated color eventually. This is some weird stuff that will go. We then basically write it out to the final output buffer. And we write it out as BGRA format. Okay, let's give that a go. This should put pixels on the screen. So, but also it could be really slow. So let's see how this goes. Yeah, I wonder if we should see if, yeah, you know, maybe it's alright. Yeah, we should probably have checked like, hey, how big are these spheres looking? And maybe we could have reduced the number of spheres that way. But let's just roll with this. We could also have reduced the number of spheres. Oh, we've got spheres cap, isn't it? Yeah. And that's 40,000, isn't it? So that should mean we shouldn't do anything too crazy. Yeah, it's 40,000. So it shouldn't fry the system. Right, so hopefully this works. If the stream dies, you know, I'll be right back. AMD, but there we go. Oh, 100 milliseconds. And we didn't see anything. How did the stream cope with that? I think we're right. Maybe it did lag a bit. But that's interesting. So what we're going to do is we're going to debug this shader. So we're going to render out some color information. So if you've got a sphere, it will show red. Or blue. Sorry, because it's BGRA. So here, there's actually this is where the spheres are. So the interesting thing is all of the spheres have been added to a single cluster or whatever, and it's so small that it's making those ones run for so long that it takes 100 and whatever milliseconds. So that's not good. But yeah, so we can actually make it a bit bigger, say. So should we move our thing closer to the screen? So as our volume instance. That's the model instance, that's the old code. Skip past this one. It's just down here. There's so much old code I need to get rid of eventually. So yeah, we want to move this a bit closer, right? So should we move to 300 and see how that looks? It's still only showing up one tire once at a time. Can I make this bigger, like 512? Right, something fishy's happening. It's not making it any bigger. It was just moving the box. If you have any spheres. So let's start off by just saying, let's just make it do the whole screen. And maybe we can do like a, there you go, so whole screen's blue. Then now let's color it such that the, what do I want to do? So if we do coordinate, coord divided by, oh, excuse me, screen dims dot x. So we just try that, we should see like a, you know, the colors on this. Oh, this should be y-axis. Yes, that's BGRA, so it's sort of messed up. Some of the, it's kind of made it blue red, sorry, blue green instead of red green. It's fine. That's all right. Lower left is black, meaning 0. Top right is 1. So we know that's working fine. Some reason it's the tiles. So see what we can do to get that to work. Hey, Eternal Divine Fox, how's it going? It's been a while. How you been? So the tile binning, why oh why? So we could choose to literally just render the biggest LOD, but then it won't have any. It won't have any spheres in there. That's the problem with it. Oh, that's another point as well. We should only bother. Right. If spheres count. No, but you keep it if it does have spheres. Wait a minute. Yes, you need to get the number of spheres. You actually need to get that here. Because you need to say... Yeah, because the else statement needs to be this. So what you actually need to do is say, well, if the spheres... Because you don't want to put a cluster to render if it actually has no spheres on it. Be kind of pointless. Do you generate quads for UI elements and draw them in shaders, or do you use sign distance functions and completely draw the UI? So I use sign distance functions, and I have like a tile-based renderer that basically processes like opcodes and does a massive switch statement. It's alright on my AMD GPU. On my Intel laptop, it doesn't like it. But it's because I went all in and bananas on the implementation. I think if I did a version that wasn't so it's probably okay if your application was just user interface. It still renders pretty quick. It's not quick enough for a game, I don't think. But it's a very flexible renderer. So if I can just dive into some of the details, you can sort of see it. So essentially you have like an array of U32 integers, words as we call them. And you make these draw commands. And they're just an array of words. And basically a draw command is a series of different instructions that go on. So you parse the first word, you get type, and it'd be like, oh, it's a union operation. And it's essentially like a virtual machine. And then the union has two more arguments. So processes the next word, it says it's a 2. And then because you got 2, it means there's 2 more arguments to process. So get the next word. It's a shape. Does the sign distance field thing. Pushes the shape on the distance stack. Pushes the distance on the distance stacks for the shape. Then looks at the next word. It's bounding box. Essentially, we encode like this information. Let's get the shader up. Here we go. So essentially, we even got like a full-on matrix in there, and we pull the coordinate. Sorry. We pull like stuff like the radius out of those words as like an argument, and we calculate distance, pop on distance stack. And then we've got like a bounding box which does a similar thing. It takes the half size and radius from the distance stack and makes pops down the distance stack. So it essentially has like a virtual machine that runs these sign distance field operations per pixel. It's pretty crazy. It's pretty flexible and amazing, the stuff you can do in it. It's just not the fastest thing, but it still runs alright. It's just not the fastest thing. So I'm thinking about what I could do. Yeah, so the basic end result as well is you can color it however you want. So by the time you do a color operation, and these are again more instructions that just happen afterwards, they have to happen at the end. First, they take the distance stack, the distance at distance 0. So the CPU would guarantee that you would have finalized your sign distance field down to a single value. And then you can take that distance and color it however you want. So it's actually a really, really cool API as well. If I go into the graphics thing and see some of the UI stuff, yeah, so you can essentially like say something like this, like, hey, got a circle there, and a bounding box. So I guess this just produces the dumbbell shape, right, that we typically use. So circle there, bounding box. And then it says union those 3 together. Okay, that's the way it works. And then color it color the result with a border of 16 pixels, and then finish it. And that's one draw command. So it's this really flexible drawing system, where essentially per pixel these things run. It's bananas. It's awesome and flexible. Like, you can do all some crazy stuff at runtime. But we should probably, yeah, I may or may not change it, where we still do this thing, but rather than doing it like we just have like one operation that does many things. So this would be like textured, or like yeah, like bordered box, textured box, I guess. And just switch on that rather than switching on every single micro operation. Have more of a CISC versus RISC, you know, design. But that's kind of what we do if that makes sense. Yeah, sometimes feels a powerful beat. You can colorize it on the fly, drop shadows, exactly, yeah. They're really cool. So I wanted to see like, what it's like if I made something super over the top kind of virtual machine type thing in the shader. But yeah, it's cool. Right, so why the hell doesn't this thing work? Um, we also didn't check if the sphere actually exists. We're just putting all of the spheres on there. We're not even checking if the sphere exists. That's the other interesting thing. So if you look where we actually did that. We didn't even bother trying to do that. How do I take a thing and flatten it down again? Cluster sphere index on it. I've done it in the past. Perfect. What I'm looking for now. Alright. So in this one where it bins, what it actually needs to do is you calculate this, which flattens it out to 0 to 63 inclusively, so you get your sphere index. What we actually need to do is say, hey, if cluster sphere index is, wait, node spheres, now we should probably actually combine the sphere bits at this point. Oh, damn it. Alright, less than 32. Yeah. Wait, greater than or equal to 30. I think it's the logic I did before. Yes. So this is actually fit into this is not a 64-bit integer, this bit set. It's actually two 32-bit integers because we don't have 64-bit support on GPU. We probably do, but just don't want to enable it. So it's just two 32s. So then we can just do, done this logic before. Pass me is on it. Right. So basically if it's not set. Now, actually we need to if not so the thing is we also have an explicit LOD spheres. Are they called explicit LOD spheres? Or exclusive LOD spheres? Yeah, so if you're rendering at this level of detail, you also have a set of exclusive LOD spheres that don't downsample to the lower LODs, in a sense. So we're saying if it doesn't have any of those, then we return. So that's something we didn't do, and I guess that doesn't help with the performance. Well, it's not correct either, just render anything. Every sphere in a cluster. So I'm curious why So we're going to debug the prepare clusters shader. Oh man, I had that code in there. I should just comment it out. I keep writing this thing out. So we're just going to write the printf again. B D left D top. Oh, why did it? And then right. Alrighty, so bottom left dot x, bottom left dot y, top right dot x, and top right dot y. So what I want to do is make it so only the first, only the first cluster gets into here. And then this way we can debug everything. Then we'll go down to the next layer and just see where all of these screen bounds end up, basically. Cool. I'm trying to find some resources on how to do it. Do you have some? Yeah. So there's some so there's basically, you know, IQ. He's got tons of resources. He's even got 3D ones as well. But these are like a list of 2D SDF functions you can use. And he has shaders you can play around with as well on Shader Toy. So you just boot these up and you can sort of have a play with them, right? And sort of get a feel for how you do it. Although this specific renderer I wrote, I do have a VOD channel, and there is, if you go back far enough, it's just not so long I've been doing this, that's right. Here's me doing the UI the immediate, right, so this is me doing the actual immediate mode UI. So where I got with that is like, it's pretty cool. I've got like a scrolling area, scroll bars, text fields, buttons, and all sorts. So I'm quite happy with that. It's got to plug it back in again. But it's all there in the code base. Obviously a very stylish theme. This is me running the renderer. And of course, also see this right here? 6 months ago, before 2024 started. And I was I've been counting the days for Mickey Mouse. So as you can tell, there we go. It's me. But anyway, so this is like the advanced clipping as well. Or it's even got like sign distance field clipping that you can also apply to those draw commands. It's quite intense. Very flexible renderer. Put it that way. Look at that beard. Anyway, but yeah, I was really happy with it though. Just unsure whether or not the flexibility is a good thing. It might be good for the game though. No worries. Yeah, also the code is up on the GitLab if you're a subscriber to Twitch or support via Ko-Fi. You can have access to the code and just look at it as well and have a play. So that's the other resource I have. Right, debugging time. So we should be seeing this printed out. Here we go. So bottom is this number, top is that number. Right. So to me, that seems quite alright maybe. Does it though? Let's take this and drop it in a new tab. You know, maybe I'll do a... Wait, I've got to do a new Vim. Right, so there's some numbers. Numbers. So we want... Should I get the other ones? Yeah, I'll make it go for a little bit longer. I'll say if your cluster LOD is 1, then you'll finish. There. So let's get these numbers now. So here's all of these guys. Now, yeah, that's correct. Missing one is fine because it's cache line aligned. So basically the furthest right, or the furthest top actually goes bigger than that. And the furthest bottom Hey Cobra Dre, how's it going? Welcome. Hey Veen. Yeah, so these are the children of this one. So I don't know why it's bigger. It should not be bigger. So what we want to do is debug render the clusters using the sphere ray tracer. So what we can do is we can say if you're a cluster, so render them all. So bin them all regardless of their... So we're going to remove that, comment that out. So we're just going to say just render it, make it red. We're also going to say, what else are we going to do? We get rid of that shader in it. Bye. It's the old binning shader that can go. What else am I doing? Yeah, maybe I can get rid of that one actually, just actually delete it. Because the code's already copied. It's got refactored. So in the tiled renderer, yeah, okay, it's just gonna render out if the tile has any spheres. Okay, so still spheres over there still. What I want to do is reattach the camera code, view from world. I want to re-enable that. So we should be able to look around and probably go over there and have a look. All right, here it is. So we're getting closer. We're getting closer. And it's getting bigger. Excellent. So we're seeing, oh, that's dodgy. They kind of disappear when you go to the side. But at least when you get closer, you're seeing what we're visualizing is the tiles that have spheres binned into them. So that's cool. Now let's take it a step further and let's remove this debugging view and actually see some spheres. Here they are in the distance. We're getting closer and closer. Right, so really far away. Oh, these are so weird. Something wrong with the binning code, as you can tell. So let's actually just move the thing. Let's disable this code again, and now we can move it. Let's actually just move it closer. Let's make it. Let's say it's 100 away. 128 away. Why is it up there? I must have messed up the It's in the middle of the screen. Maybe that offset was wrong. I still don't think it. Let's remove that offset that we did. Prepare clusters. No, the prepare clusters doesn't do that. So the prepare clusters. I also think, because I never built a 2D UI system, I think I'm overthinking it. Yeah. It possibly, like, that's very probable if you haven't done it before. Definitely overthinking it. But yeah, one simple way you can do it is just literally, like, you got a triangle renderer, right? I'm not doing triangles, so my one's a bit of a different one. But if you're doing triangles, right, draw a quad for everything you want to render on the screen. You can make it fit more perfectly later on, but just draw an axis line bounding box. 2 triangles. And from with this in the pixel shader, you can have a switch statement to say, hey, which thing am I drawing? And the pixel is going to go over that switch statement. And then it will be like, oh, I'm rendering a bordered box. And then it can color it accordingly. And it can even do rounded edges because it knows it's got a radius parameter passed in and it uses that. And only from within the box it will do this sign distance field stuff. So you're not doing a full screen one like mine is. Mine's like a full screen one on a tile Bennett because I'm not using the triangle rasterizer. And when you use the triangle rasterizer, you get the benefits of being able to just place a ton of little triangle objects, and the hardware is going to do the front to back or back to front ordering. Sorry, the way you issue them, the triangles get they write to the buffer in the right order, right? So you can do the alpha blending back to front or front to back, however you want to do it. But yeah, so just do it this way, and then if you want to do a sphere, you just draw a box, right, which is 2 triangles, and then just do like a sphere. And each pixel would just do that length op from here, right? And just check to see if the length of that vector from the middle of this thing is less than or equal to the radius, and if it isn't, it's not colored in. If not, it's colored in. And you can do stuff with borders if you want, and yeah, that's what I'd do. If you the implementation I did was just very flexible render, and it's constrained with compute only. So if you've got triangle rasterizer, that's probably the best approach to do. So why is it near the top right? Good question. So I don't think it's to do. Ooh. So the spheres put themselves there. So something I want to check actually is when we bump allocate. Spheres. Oh, where is it? It's tile bin. When we do the binning, I can prototype in WebGL. Fair play. Yeah, that's what comes to win. Give that a go. Yeah, C is the way. So the thing I want to check is actually are these spheres going into buffers that don't have anything allocated? So if insert index overflowed spheres. Insert index spheres cap. Yeah. Let's see that because yeah. Oh. Right, as I expected, the spheres, the capacity is 0. So this means that the spheres the cluster and the spheres are in two completely different places on the screen. So it's not pre-allocating the tile bins correctly. So what's happening is, to draw it, something to do with the cluster is kind of being positioned here or something and saying, hey, these guys need to be, you need to allocate some space for some spheres, right? The maximum number of spheres that I have, just in case, right? But then the spheres are actually being drawn over here. And so something weird is happening. So what we need to do is also print out some sphere bounds. So what I want to do is grab that other print and do, instead of write sphere, so bounds, 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 W and Z. Bam. And then I want to reduce the amount of, we'll just render the first cluster. First LOD, and we'll just put all the spheres in there, even though there's not actually any spheres there. We'll just pretend they're all there. Right, so now we're seeing some information. Oh my days, holy moly. This is a floating point number printed as an integer. Clearly understandable by a human being. Not. So we're just going to correct that. Put some F's in there. My first programming language, which I need to learn, was assembly. I was on our school programs and microcontroller. Oh, nice. That's awesome. My first one was JavaScript because I didn't know about where to look for resources and that. And then I discovered more things about C and C++, and I was like, this is so hard. I'm never doing this. And then eventually I just got into it. Because I just was like, I want to know how to, the gap in my knowledge was missing on how to create an actual proper executable, right? And not something that runs in a web browser. And this was magic to me. I wanted to learn about how to do that and everything about that. And then eventually I got into learning about pointers. Pointers felt so damn hard for some reason. I don't know why. But just the fact about pointers, and then I think I was learning C++ at the time as well, so it made it extra hard. And you'd write stuff into a vector, and also I was probably looking at like C++ reference docs for like standard vector, and seeing just like template stuff everywhere and completely unreadable. And also then I'm inserting stuff into a vector, and I got a pointer to somewhere in there, and I push more stuff, and then it reallocates, and my mind is like, oh, what's going on? But yeah, I got over that eventually. Went to C. Yeah, C++, man. It's just out there to confuse every new person. And then they go and do Rust or something. So what are we thinking? Yes, does this go out of bounds in any way? Right, so all of the spheres that... Like the bottom is never that bottom. And the top is never that top. What the living what is going on? It's actually within the bounds. The left, however, is bigger and smaller. What is going on? This is in the space. So that's fine. It's not exactly like... People with template stuff shiver me down the spine. Yeah. I know, right? Especially the documentation around it all. Hey Rasmusko, how you doing? How's it going? There's in view space. We're in view space. Yeah. Does all that. I think that's alright. I think that code's alright. So... Why oh why? What was I doing again? Yeah, view from local, it's alright. Yeah, so perhaps maybe yeah, perhaps maybe the capacity. So I should kind of see like what tiles we are going over. So tiles capacity, so this is the allocator. Yeah, the allocator's alright. So I kind of want to know like what tile we're. Oh, the spheres count. Right, of course it's going to be 0. Whoops. Let me hardcode that as well. Spheres count equals 64. Ding. Yeah, we're pushing on something that does actually have. Like we're debugging by doing the first LOD, which doesn't have any spheres. Right, what we've got now. Still overflowed. Alright, still got an issue. Damn it. So now we can print out like GPU hprintf, tile index. So let's just print out all the tiles that we still struggling with multiple swap chains. Damn. What's the problem exactly? Is it doing the different renders and stuff? Right. I wonder why this is such a big linear set of range of. Numbers. Maybe it does do some skipping. But yeah, so we're about. Seriously though, why is it? Yeah, maybe I should, rather than print out that, like an absolute weirdo, why didn't I just print out? Print out like this, right? Tile, top, right, and all that crap, right? They're using. Right. So we'll take this and we'll take it to the sphere code. Wait, is that doing it yeah, once. Excellent. So do that once per sphere. Put it here. And I think it works off of the bounds code as well. And it uses floats. But yeah, floats. We could cast it into ints. We should probably do silence, but hey. It's just quick code. Sphere. The problem now is that one is using multi-view and the other isn't. Right. Yeah, I know what you mean. So I probably need to make an extra render pass to duplicate the pipelines. Could you just add another multi-view layer? Right? If I remember that correctly. Could you just add, or do the viewports have to be the same size? You get a view index. Oh yeah, but you'd have to do different. Yeah, but you have to do different render paths anyway, right? Because you're rendering a different you're doing a different different fragment shaders anyway, right? So they're gonna have to be different. Different shaders that run, right? Yeah, you have two different render paths. That's right. Yeah. Yeah. Okay, so these tile coordinates. I might not. Oh, screw up. No, both. Okay, so basically 44 to 80 at the top, so it's going to always the top of the screen. 34 to 60. Um, I have two different render passes now, but I need an additional to go from 2 to 1 layers. Alright. Function always pass by value, yeah, basically. Yeah, unless you explicitly take a pointer to it and make it a pointer type. Uh, yeah, something's really off with this bounding box. It's really big. And it goes early. Yeah. Always the mass is just different to the sphere and that. But it's covered though. It's completely covered, so the it should not be doing this overflow. On the tile. That just doesn't make any sense. So I wonder what else we've done to bugger this up. Reading the tiles. Bump that. Spheres cap. Here we probably want to say tile index, spheres cap, and just print out those two guys. Just to say, see if we actually have allocated any with some kind of capacity. No worries, no worries. Right, let's go up here. Okay, so some that get allocated with 64, they're like 3,000 odd, 4,000 odd. Right, but there's some. I should probably make those into like proper coordinates. So we do like remainder sphere ray tracer tile grid dims. So how many tiles we've got along the X, and then we'll do a divide, and that goes to the Y. Right. So basically tile. So we look for tile 57. Or 47, 57. Yeah, 47 times 57 has this, but later on it doesn't. So that is weird. Can we sort of like move that code down here and do we get that stuff printed out? Still, like, is this being set to 0 or something? No, it still gets applied. So am I giving it the wrong tiles buffer or something? Tiles is tiles and that's spheres. Read write. Yeah, read only. Read write. And read write up here. The correct buffer that's going in there. In the prepare shader that we've been using. So that's weird. Unless the code is grabbing the wrong tile. In the renderer. But yeah, no, it still doesn't account for the fact that there's this overflows here. Very suspect by this still. Why does this overflow? Like, how has the capacity... So it's definitely been set to 64 just fine. And even in here, it's still 64. When it does the final write. But when we load it out in the binning code, these tiles. I wanted to keep that one. That's the old one. It's tile bin one. So how is it when we bin these tiles? This all looks correct to me. Alright, let's take a look at this again some more. So maybe here we'll print out the coordinates. We'll do a similar thing to what we did. Tile this by that. So we'll just do tile index mod that, tile index div that. Let's try that again. So let's look at 56. Sorry, 57, 40. Wait, are my coordinates the wrong way around? The x and y's. That remainder is correct. To mean x. Divide is right to mean. So y then is my... So I think my x, y might be the wrong way around. So this is not the x coordinate, right? It's the bottom, it's the y coordinate. It's on the left. So, but yeah. So I think what could be going on then? $57, 40. What was it 57? What 40? $57.46. Yeah, we didn't really allocate anything there. 57.46 in all of these guys. That specific one at least. Yeah, I think maybe these are the wrong way around somehow. How can the XY be the wrong way around? Oh my days, I did my naming wrong. That's why. So it's just the debug code's a bit wrong. So this one will be left, bottom, right top. Okay. I gotta correct that in the clusters as well. Left, bottom. Alright, let's try that again. Okay, so now the crap is that. So the tile ones have still not been named correctly. Left, bottom, right, top. Left, bottom, right, top. Okay, let's try that out again. Right. So 56, 46. So these are the only ones that didn't make it in. 57, 46 here. So this sphere tried to push into that tile and it didn't kind of work. So, but if you look at the, oh, we didn't push the, is there not enough spheres in it? It can't allocate anymore, maybe. Yeah, maybe we're doing too many, we're rendering too many spheres still. That could be what it is. So, why are we getting that problem? So you're going all the way to 80 and 60. That doesn't look correct to me. Something off with that. That goes all the way to the edge of the screen. That's not right. Maybe the offset is just wrong. I don't think this is... I think this should exist though, the offset, that final offset. My days. Right, so that starts from tile 4. Or it's tile 58. That's not right still. Okay, so there could be something wrong with the translation between view space and screen space still. No, it is just adding the half. I think it should be right. Yeah, it's offset from the screen still, which is the confusing thing. It's not down the middle where I think it should be. Need to look into that. But yeah, so I think it's overflowing because we've actually got more spheres. I'm not sure how many tiles we're doing, but it's quite easy to work that out. So it's 54 times 54. That's how many tiles, then times 64, and that's how many spheres. And we've only got 40,000 spheres in the spheres buffer. That's the reason why we're not getting spheres completely in some of these tiles. Because it's, yes, maybe the over allocating strategy might be a bit. Maybe it's alright. Maybe we just up the number of spheres. Let's just up the number. Let's put another 0 on there. Bit big though. Let's do 200,000. Smaller. Right, so now we're not getting any flickering. It's up there though, which is confusing. So we're not getting any sort of like problems where we overflow the buffer. So that's good to know. I want to comment out that then. And then probably this one as well, because there's just tons of data coming through now. There's our spheres up here. I expect this to be in the middle of the screen. And I'm still confused why that it's not there. Like, why should we be firing a ray up there to render something that should be kind of in front of us, I think? Because the view from... Let's really close this one. The view from world is just identity. So it's not even moving the world anywhere. The world from local is literally, it's got some Z and it's got some scaling. That's it. So there's something a bit skeptical about how we're making these bounding boxes, I think. So we look at the coordinates. 700 left. So it kind of goes off the screen because the screen is, or the window is 1280 by 960 or something. So it goes off the screen for some reason, which is not good there. If we go back to that code, which I commented, I went to go and comment out, then I put back in. That is in prepare clusters. LOD. Here we offset it in screen space. So like, I expect it to be in the middle. Does this get me anywhere near the middle in some way? $70 left, 900 odd right. That's huge. See, is the problem that I need to sort of divide by 2 or something? Because it's going from like signed space to unsigned space. Is that kind of what the problem is? That I've been missing out on, maybe? Let's check these numbers now. Right, this is no. Yeah, so this is kind of better, I think. It's going all the way to the right of the screen, but from the middle. So I think the object's not centered now. I think, okay, let's apply this to the other code, which does the spheres. And then it will bring the spheres into the right place as well. But I still think this is wrong. I need to think about it proper. So this is in the binning code. Calculate the screen bounds here. So in this one, yeah, something's really wrong, and I don't quite know yet. I'm not seeing anything on the screen, but it's within the pixel range. So it must mean because I haven't pushed it far enough out. Let's push it 512 again. Why can't I see anything now? Yeah, the bounding box is a little bit off as well. That doesn't go all the way to 700, but it gets... Wait, there's not even a pixel big. A bit far away in it. Now they're bigger than a pixel at least. Why, oh why? So why has it stopped rendering now? We use this function in one place that we care about, right? And I will get rid of these excess functions, they're just in the way. Alright, let's print out this. They should be binning it in tiles. Yeah, it bins it into some tiles, they get binned. So where's that tiled shader? Tiled ray tracing shader. Let's enable that. So this prints out, this debug renders the tiles if they have any content. Right, so they're here apparently. But I don't see them. So what are they in view space? What's their depth? What's their Z? Oh, let's give that a go. Oh, I didn't reach that far, of course, because I've got this return happening. $300 odd. Yeah, I think that's fine. Yeah, it's off into the distance. So do no rays hit the no rays hit it? Maybe is it too small? Bring it closer maybe? Let's do, bring it down to 128. Oh. Alright, about 200 now. Z for all these spheres. Let's debug visualize that. So it's there. That's where the spheres are being rendered. Let's see if we can move them a bit closer. See what happens there. Got a bit bigger. What about... Oh, this just feels weird. Why? Okay, 2 tiles are visualized now. Still seeing nothing show up. What did we change that buggered this up? Oh yeah, we did this sort of divide on the screen, calculate screen bounds, wasn't it? Can we do these instead? Oh. But the ray tracers probably needs to be adjusted now as well. Because the ray tracer's ray is... Or the view position might be wrong. No, it can't be. Yeah, something might be wrong then with the ray. This coordinate is 0. Oh, this could have been the problem the whole time. The coordinate is 0 to 1. Sorry, it is 0 to the screen size or whatever. That's not the UV, is it? Oh, UV. Subtract. Dims divided by 2. I guess UVB is 0 to 1. Yes, that'll give you a signed norm value. Well, 0.5. Negative 0.5 to... This will give you negative 0.5 to 0.5. Because this is 0 to 1. No, it's not 0 to 1. This will give you negative... Yeah. Positive, something like that. Yeah, so that'll probably work alright. Yeah, something's not right since we've done that. I don't know what it is now. Since we've done this divide by 2. And made it like the other one. I don't know what it is. Yeah, we bring those back. They are here. Nope. But they're kind of up there in the sky. It's weird. We can kind of fly over to it as well. We just enable the this code here. So we've got a view from world. There it is. sums up with the renderer. It's probably the way it calculates the bounding box is probably not right at different viewing angles. It's got to correct that code as well. When you go behind it, it's probably a bit weird. Hmm. Alright. Okay, so it's kind of getting a bit late now, so I think I'll just call it quits there and figure out with a fresh mind like what the problem is next time. But at least we've got something rendering. But yeah, it's more debugging to get the full volume working. So next stream will be on Thursday at 6:30 p.m. GMT plus 1. Yeah, we have a VOD channel. We're going to catch up on VODs, see what we've done in the past as well to build this engine for this game. But yeah. Okay. Let's find someone to raid quickly. No worries, Pete. Peter. Pete Riggs. Thank you. Thank you for coming, guys. It's been really cool. Made some progress. Yeah, I'm not sure if I can find anyone, to be fair. I might just nick the stream. But yeah, thank you for coming, everyone. I'll see you all in the future one. Have a good tomorrow. It's my birthday tomorrow, actually, so I'll have a good tomorrow. Gonna have a meal out with my wife.